Hello everyone. For the lab of today, we'll be studying about JUnit. This is where you define a set of functions and you want to see whether or not the result is the one which you expect. So this means that this is the one used. J comes from Java and you have just a bunch of small functions which you want to test. So you will have this at, okay, in before the method at test, and you want to see whether or not the result is the same, and it will simply show whether it is validated or not for each and every function call. Such that you simply, before using a function in production, you have to test it. So in several scenarios based on several inputs, such that you will have less errors that can appear when another user, someone who doesn't know your application, will simply test your program. So in this case, you don't need to just do it manually. You just assert some situations and then you see whether or not you have the expected results or which would be the error. So for example, here we've got a method to multiply two numbers. You multiply A and B, okay? And what you will do is, in fact, that you will have a Java class, and then inside you can have the JUnit. So let's see here, inside what you have, you go to File, then you have Project Structure, and when going inside Libraries, you see that from this plus, you will have exactly what you want to take, okay? And you will have several names, like you will have the JUnit for it. It will be, this is the Maven one. So you have the plus from Maven, JUnit, and then the search one. It takes some time. I also will be sharing the first time I didn't wait. Okay, so you have here several versions which you can use, and the one which was used by me is this 4.13.2, and you have the file locations of your Maven repository. So Maven is simply used that based on XML structure. You've got the nodes and you've got the version, which is the program that you want to install. You simply assert and you say that you've got exactly that JUnit program. Okay, it's a library. And also you can have test modules. So you can assert which would be inside a test module. So here you can click on this one, okay, and this you transform it to be test. So you can have resources, you can have sources, like you have this job, okay, and it will appear differently inside your structure. Okay, so you can also add some content to it. You can add a new folder, okay, and you just add them one by one. So let's say that we have this folder, okay, and you will have a new application. So you have a new Java class, and in this one you want to have a test for multiplication. So let's say multiplication test. Okay. What you will have inside is this function based on multiply. Okay, so you will have the public int multiply of int a int b, and here you will simply have the return of a times b. This is just the beginning, because then you have this assert equals, and don't forget that you've got the at test in front. So this is how you define test methods. You have at test, and then you have this public void multiplication. Okay. By 0. Okay, we can have the multiplication amount test, let's say. Okay, and here you would have simply you need to assert whether the result is the one that you would like to receive. So let's have the constructor first of all. Okay, and in this one you have a new multiplication test calling the default constructor, okay, by default, and you have this assert equals. Okay, and for this assert equals, this is the one that, okay, you have the JUnit test, and you also need to have the import of the static org.JUnit. After the unit you have assert, and you have assert equals. Okay. So inside this assert equals, you would like to see whether, let's say we have 10, this one multiplied by 0, okay, this has to be equal to 0. You want the result to be 0, and you have this test dot, and you call the method which is multiply of your values, which are 10 and 0 as here. So you have this run button, okay, and it will say that it is all right. Then if I expect to have the value 1 and I run it again, it will say that the expected value, the one which I added, is 1, but the actual value is 0. Okay, so you have this failed equals that isn't validated. And this one you can store it as multiple test. Can be 1 and can have 2, and this one to be 0. So I can run both of them. Okay, as you can see, the second one is validated, and I have nothing. It was even the time, how much time it took to be executed. So to return all these crashes, so where exactly it crashed. Okay, so you have the whole detail, and you see here, okay, which is exactly what you expect and what is the actual difference. So you can have several cases inside that you can assert, and you simply see one by one which would be exactly the value that you would like to receive. Also, what you have over here, okay, this is just based on it. You have a test, so you have this at in front, as you have this at test over here. You can also have the expected exception, which is triggered. Okay, so you have this assertion error. Okay, so it depends on the error that appears. You also have a timeout, how much time it took in milliseconds. Even here you have it in milliseconds, 7 milliseconds. Then you have it step by step. You can have this before. So whether you execute it before each and every test, maybe you want to initialize something to read, to initialize a class, or it depends. Maybe you've got some variables that you need to set, or maybe you analyze some students and you know since the beginning which is the list with each and every student. Then you also have the after, so after a test, what you want to do, whether you have some logs or temporary data, or maybe you want to save. Okay, so maybe you want to say what is the output, like you have a counter. You also have before class, so this refers to classes, what you need to have it done, and similarly based on a method, you also have the after class. Also, you can have the ignore, so it will simply have the ignore of the test method. So as you can see, when I click on this run, it will have the whole test, and I can also have the ignore for it. And as you can see, okay, you need to define it as org JUnit ignore. Okay. So you need also to import it. Okay. I need to put assert and this assert equals, and you need to also import this static org dot JUnit, and you also have this ignore. Okay, and you can have multiple options. I can add them by this one, but this will be with assert equal. So yeah, having star and JUnit. So it depends on the option that you want to have. Okay, let's see, import JUnit org. Yeah, wow. Okay, so it wants it just to have to be without the static in front. Okay, so if you run it, okay, you have just the second method. Okay, this one was ignored. Then you also can say why you disable it. Maybe you don't use it for a certain version of your application. Also, you have a fail message. You have the assert rule based on a condition. Okay, whether you have your multiply, like here you can call a function. Okay, whether the result is the same, assert true, assert false, whether it's equal. So you have like in Linux. Minus, I mean whether it's true, false, whether it's equal to it. Also, you have the null, whether the object is null or not null, or whether you have expected and actual to assert, whether they are the same or not the same. So here what you will have to do for the first exercise, you have a list with an array, and you have the remove all, such that based on A you want to remove all the objects of that type. So first of all, you need to think of preconditions and past conditions, as well as you have the case when the list is empty. And also you've got a list, and this is an array, so you have a certain capacity, and you should not exceed it. Then for the second exercise, this is when you solve a second degree equation, and you will have this double degree of ABC. And you have to find out which are the solutions for it. So you will have this double degree test. And in this one, you will have firstly, let's import, and it was org JUnit. And this is for test. And we also have the import of static org.JUnit. Then we have assert, and we have assert equals. Okay. Now for it, you will have this double degree, so you need to find out which is the result, and you have two values, x1 and x2. So you have this double degree. Okay, and for it I have my int a. Okay, I have my int b, int c. Okay, and here I have my solutions. So being 2, you have to with plus minus. All right, then we have this double x1, which is what? You have that minus b plus, and you've got the square root of b squared minus 4ac, and you need to divide everything by 2a. So this means that inside we have this minus b, then you have the square root. Based on the square root, you have b squared. Based on that, I need to subtract 4 times a and c. Okay, what I've got inside, so for all of this, okay, I need to have it divided by my value. Okay, so I need to divide it by 2 times a. Okay. And this is the first one, and then you have the plus, and you also have the minus for x2. Okay, so here you will have the minus. Then now you need to check which is the solution. So you will have if this x1, okay, you will have it here. So I have the first, whether this x1 is equal to math floor of itself, of x1, okay, and you also want it, okay, not to be infinite. So this one, okay, not to divide by 0, whether a is 0 and then you get infinity. So you have this, whether is different, that double is infinite of x1. Okay, then what I will have here is the source of 0 will be equal to the integer part of my x1. Okay, and whether it's not, I will simply have my x1 equal to 0. Okay. Also, what you have here is that you have the second part where you have x2. So you also compare x2, whether it's the same as x2, and whether it's different than is infinite of x2. Okay, meaning that this one you store it inside solutions 1 of x2. Okay, and else we will have this x2 equal to 0. And what I will do now is to return what? I will return my solutions. I will return this array of solutions. Then what I will like to do is to test everything. So we will have a method, a test method. So this is why you put this add. You have a public void test. And in this one, you want to have such a double degree test. Okay. And let's say it's DG as being new double degree test. Inside it, I have this assert equals, and you can add some, let's say this x squared minus 4, right, with this 2. And now I will have my dg, for which I want to call the function with double degree based on ABC. So here my a, so you have ax squared plus bx plus c. It means that this one, a is equal to 1. Then you see that you don't have any member with x, meaning that b is 0, and my c is minus 4. Okay, and you will have each and every solution. So you will have the position 0, whether or not it is true, as well as based on it, I have this one, and for it I have this minus 2 based on my second solution. So I test this one. Okay, and it is true. So this 2 with plus minus, it will be equal to 0, so it's fine, it's a solution. And here, whether I put the 3, okay, you will see that this one will fail, and it tells you that the actual value that you should have is 2. So you can also write to other equations, like, let's see, you have assert equals, and you can also have, let's say, a plus 6x, then you have a plus 9, and in this case you will have this minus 3. You see here that you have a equal to 1, b will be 6, and you have c as being 9, and you get the first solution. Then based on it, I want the second solution, okay, that you can have, okay. So you can even make this one. Let's see if we put it also to be in a second. Okay, and here if I put something else, it should tell you what you expect. Okay, so it is this -3. Okay, as well as based on this example, we can have x squared, even let's say we have 2x squared, and I simply have this 7x, and then we have a 3, and I want this value to be 0. Then my a will be 2, my b will be 7, and my c will be 3. So I want the first solution, which would be, okay, and I would also have the next one, which is -3. So if I run it, okay, it says what you expect to get based on each and every solution. So this is for one, but for the second one, okay, yeah, now it proves to be correct. So you have x1 and x2 based on this plus and minus respectively. And this is what you need to test in order to have the whole solution for this whole exercise. I thank you all for your attention, and if you have questions, you can ask me. Thank you.